Okay, we're on lesson 27, unit 5 of the pre-calculus book on page 305, solving right triangles. If you look at that, there's a chart on page 305, and we're going to fill this chart in from memory and using what's positive or negative in what quadrant and using reference angles. So for those who are struggling with what's positive where, this is a good review. And for those who are struggling with reference angles, this is a good review. And for those who haven't done the initial memory work, this is a good review. The first thing we need to know is that in quadrant 1, what's positive? They're all positive. In quadrant 2, what's positive? Sine only. In quadrant 3, tangent only. And in quadrant 4, cosine only. And the way we memorize that is A, SMART, Trig, class. If you need an acronym, A, SMART, Trig, class. They're all positive in quadrant 1. Sine only is positive in quadrant 2. Tangent only is positive in quadrant 3. And cosine is positive only in quadrant 4. Now, we know that to the right on the x-axis is 0. Straight up on the y-axis is 90. To the left on the x-axis is 180. And down on the x-axis is 270. One of the things you have to do is visually be able to place an angle in a certain quadrant. In other words, if I said 135 degrees, you would need to pretty quickly be able to say that's in quadrant 2. Or if I said 225 degrees, you'd need to think, well, 270 straight down. So it didn't quite make it to straight down, so it's over in quadrant 3. You see what? You're going to have to kind of be able to think that to get your right quadrant quickly in your head, okay? And then work those reference angles out. But we'll deal with that as we go through. Now, first of all, we're going to just get the memorized ones, okay? And we've already taught why they are what they are with 30, 60, 90, 45, 45, 90 right triangles, so we're not going to rediscover it. We're just going to show what we're supposed to memorize. So I'm going to put all the memorized stuff in green. Now, the sine of 0 is 0. The cosine of 0 is 1, and the tangent of 0 is 0. That's just flat memory work. You just need to know that forever. The sine of 30 is 1/2. The cosine of 30 is square root 3 over 2. And the tangent of 30 is square root 3 over 3. Again, memory work. The sine of 45 is square root 2 over 2. Cosine 45, square root 2 over 2. Tangent 45, 1. The sine of 60 is square root 3 over 2. The cosine of 60 is 1/2. The tangent of 60 is square root 3. Very good. The sine of 90 is 1. The cosine of 90 is 0. And the tangent of 90 is mathematically undefined because you would have a division by 0 error in the calculation of it. Those are what you're supposed to memorize. So you just take the time to memorize them. Write them, say them, record them, and listen to it, whatever you got to do. Put them on your iPod if you need to. That's what I do when I'm trying to memorize some things. I write it. Sometimes if I'm having trouble, I'll say it, and then I'll play the recording and listen to it. Anyway, whatever you got to do to memorize it, memorize it. There's only 15 things to memorize there. Now, the rest of this comes from reference angles. And I'm going to draw a picture every time we do one from now on just so you can see it, okay? So, now we're to 120 degrees. 120 degrees. Now, that's 180. Where's 120 degrees going to land? It's going to land 60 degrees before 180 degrees, right? It's in quadrant 2, 60 degrees before 180. So what's the reference angle? 60. So my reference angle is 60. So all my answers for 120 are going to look like my answers for 60 because the reference angle for 120 is 60. Okay? But now I got to think about the sign. I'm in quadrant 2 where what is positive? Sine. Okay, so 120 is like sine of 60. So we're thinking, what's sine 60? Square root 3 over 2. But is sine positive or negative in quadrant 2? Positive, so it's positive. Okay, cosine 60. 1/2. But is cosine positive or negative in quadrant 2? So it's negative 1/2. Everybody see what we're doing? Once you know your reference angles and what's positive or negative where, and the green stuff, you can fill in everything else. Okay? All right, so reference angle 60. What's tangent 60? Square root 3, but we're in quadrant 2. Tangent is negative in quadrant 2, so it's negative square root 3. Everybody understand that? Okay, I'm going to use a different color. I'm going to wipe this out. We'll get the next one. And I'll get out of your way in just a second. The next one's 135 degrees. That means we start here. This is 180 degrees. We're going to go past the 90, so we're going to end up over here somewhere. We're in quadrant 2. We're how far from the 180? 45. So my reference angle is 45 degrees, and I'm in quadrant 2 where what is positive? Sine only. So we're not going to be thinking 135 degrees. We're going to be thinking 45 degrees, and we're supposed to have those memorized. That's all the green stuff. So we're thinking sine 45. What's sine 45? Square root 2 over 2. Is sine positive or negative in quadrant 2? Positive, so it's positive square root 2 over 2. Instead of thinking 135, we're thinking 45. What's cosine 45? Square root 2 over 2. But we're in quadrant 2. What's cosine is negative in quadrant 2. So we have negative square root 2 over 2. The reference angle for 135 is 45. What's tangent 45? Square root, it's 1. Tangent 45 is 1. And we're in quadrant 2, so it's negative 1. I understand so far? Okay. Next one. See, this is just going to be a good review of using our reference angles and stuff. Okay, so we're talking about 150 degrees. This is 180 degrees. If we go 150 degrees, we're how far from the x-axis? 30 degrees. So my reference angle is 30 degrees. So instead of thinking 150, I'm going to be doing my memorized 30. We're in quadrant 2 again, where sine is positive. So what is sine 30? 1/2, and we're in quadrant 1 where sine is positive. What's cosine 30? Square root 3 over 2. We're in quadrant 2 where cosine is negative. What is the tangent of 30? Square root 3, and we're in quadrant 2 where tangent is negative. Everybody see that? Hopefully this is going to get better and better. Okay? I know some of you yesterday didn't understand everything I'm saying today. Hopefully today you understand it. Okay? All right, so let's move on over to this side. And what I'm going to do is I'm going to wipe out the bottom because I need a place to draw pictures. Okay? I'm going to leave the green memory work. Has everybody got this down here so I can get rid of it? Okay, so we're talking about 180 degrees. Now here's the deal about that. $180 degrees and 0 degrees are the exact same number. But when you go from the right to the left, what's going to happen? It's going to change signs. Okay? So you're going to use, for 180, you're going to use your 0 stuff, but you're going to change the sign. Okay? You understand that? This is the rules for quadrantal angles. That's what we call 0 and 180. 90 and 270, they're quadrantal angles. 180 stuff is the opposite sign of the 0 stuff. Okay, so let's run through those then. When we're thinking sine 180, we're really thinking sine 0 but opposite sign. What's sine 0? 0. What's negative 0? Well, it's still 0. So it's the negative of what it was for 0, but negative 0 is still 0. 0 has no sign. Okay? Okay, what is the cosine of 0? 1, but for 180, we want the negative 1, the negative of the cosine of 0. Okay? What is the tangent of 0? 0. What's the negative of that? Well, it's still 0 because 0 has no sign. Okay? So we messed with a quadrantal angle. Now, let's skip down to 270 since we're on quadrantal angles, and let's deal with another quadrantal angle. We've got 90 here and 270 here. If we go from here to here, we change the sign. So for 270, you're really going to look at 90 because it's the opposite quadrantal angle of 90, and you change the sign. Understand that? So for 270, you're thinking, okay, what's the sine of 90? 1, but I need the opposite sign, negative 1. For 270 cosine, we're really thinking 90. What's cosine 90? 0. What's the negative of 0? 0. For tangent 270, we think tangent 90. What's tangent 90? Undefined. Well, it's still going to be undefined. We still say undefined. Everybody see how we got our 180 and 270 quadrantal angles. What about 360? Well, it's the same place 0 is. It's exactly the same thing as 0 because it's back to 0. They share a terminal side, right? They share a terminal side. And if they share a terminal side, then they're the same value. Okay? And then they're in the same quadrant or on the same quadrantal angle. Okay, so 360 is right back to the beginning. Okay? Now let's go to 210. 210. So I'm going to think about where that's going to land me. Okay, this is 180 degrees. This is 270 degrees. If I go 210, I'm going to start, and I'm going to go past 180 by how much? 30 degrees, you see, past 180. So what's my reference angle? 30. So if I'm wanting to find sine cosine 210, I think, well, where does that put me? Well, it put me 30 degrees past 180, and so my reference angle is 30, and I'm in quadrant 3 where tangent is the only thing positive. A smart trig. Tangent is the only thing positive. Okay, so for sine 210, we're thinking sine 30. What's sine 30? 1/2, but we're in quadrant 3 where sine is negative. What's the cosine of 30? Square root 3 over 2, but we're in quadrant 3 where cosine is negative. What is tangent 30? Square root 3 over 3, but we're in quadrant 3 where tangent is positive, so that one was positive because tangent is positive in quadrant 3. Is everybody understand what we're doing? Any questions? Because you've really got to understand what we're doing today. This is like super review day. Okay? Okay, very good so far, it appears. Let's go to the 225 then. 225. All right, this is 180 degrees. This is 270 degrees. We haven't made it to 270. We're over in here somewhere at 225. That's 45 degrees past 180. 225 is 45 past 180. So my reference angle for 225 is 45. I kind of lined those up on purpose. I don't know if you did or not. But anyway, so what is my reference angle is 45. So when I say sine 225, my reference is 45. Sine 45 is square root 2 over 2, but we're in quadrant 3 where sine is negative. Okay? Cosine 45, square root 2 over 2. We're in quadrant 3 where cosine is negative. Tangent 45, 1. We're in quadrant 3 where tangent is positive. You see that? Okay. See how important it is to know the first 15 green ones? You just got to know them. Look at how many radicals there are. Your calculator's not going to kick out that radical. There's calculators that will, but we haven't let you have those here. Because we want you to have to memorize this because it's good for your brain. I've got a calculator that'll kick out those radicals. But anyway, and they make about a $20 one that'll do it too, but we're not going to tell you about those right now. Anyway, I wouldn't let you use those on the test if you had them, by the way. Anyway, number 240. There is an application in the TI-84s where it will let you do it, but we cleared the apps, so it doesn't work, and I won't let you use those on a test. Okay, 240 degrees. Let's see what we got here. But see, it's like not knowing your multiplication tables. You can do your multiplication on the calculator, but it sure is a handicap. And it's a handicap not to know this. Okay, we're talking about 240 degrees. 240 degrees, this is 180, this is 270. You don't go back to the y-axis, you go to the x-axis, right? So when we're at 240, we're going to look at how far we went past the x, right? Which is 60 degrees past the x-axis. So my reference angle is 60. So when I'm looking at 240, I'm really thinking about its reference angle 60. So we're thinking, okay, what's sine 60? Square root 3 over 2, but I'm in quadrant 3 where sine is negative. What is the cosine of 60? 1/2, but I'm in quadrant 3 where cosine is negative. That's a 2. Let me get that done. And then tangent 60 is square root 3, and we're in quadrant 3 where tangent is positive. So we're able to do that. Okay? All right, now we've got 300 degrees. Now, this is 270, and this is 360, and we would start here, and 300 would go to there, right? Now, how do we get our reference angle? We go to the nearest piece of the x-axis, My reference angle is from here to the nearest piece of the x-axis. My reference angle is 60 degrees. You understand that? To the nearest piece of the x-axis. Now, I'm in quadrant 4, and what's positive in quadrant 4? Cosine. So when I'm thinking 300 degrees, I'm using a reference of 60 degrees. Okay, so what's sine 60? Square root 3 over 2. We're in quadrant 4 where sine is negative. We should memorize some of them by saying it this many times today. What is the cosine of 60? 1/2. We're in quadrant 4 where cosine is positive, so that one's positive this time. What is the tangent of 60? Square root 3, but we're in quadrant 4 where tangent is negative. Okay? And we're going to take the time to do all these just because we need the repetition. The repetition is good for us here. All right. 270 degrees, 360 degrees. This time we're on 315. How far away is that from the nearest x-axis? 45 degrees. So my reference angle is 45 degrees. So when I'm thinking sine 315, I'm really thinking sine 45. What's the sine of 45? Square root 2 over 2. Positive sine is negative in quadrant 4. What is the cosine of 45? Same thing, square root 2 over 2. Sine is positive in quadrant 4, so that's a positive. Tangent 45 is 1, and tangent is negative in quadrant 4. And one more, we're doing good. All right, we're going to go 330 degrees. So we're going to start here. 330 degrees is how far away from the x-axis? 30 degrees. 330 degrees is 30 degrees away from all the way around. So my reference angle is 30. It's just going to bug me if that's not there. Okay, so what's the sine of 30? 1/2. I'm in quadrant 4 where sine is negative, negative 1/2. What is the cosine of 30? Square root 3 over 2. I'm in quadrant 4 where cosine is positive. What is tangent 30? Square root 3 over 3. I'm in quadrant 4 where it's negative. Okay. We're going to leave the green stuff up there, and then we're going to talk about the rest of today's lesson, but I'm going to leave that so we can refer to it, okay? Because I'm going to mess with, we're just going to play some answer the question games to get the rest of the lesson down, basically, okay? I'm going to write some rules. Has everybody got all of that? I'm leaving the green. All right, so the green is in our permanent memory, or it will be soon. Okay. What we want to talk about now is reciprocal functions versus inverse. Or arc functions. What is the reciprocal of sine, cosine, and tangent? We learned that the reciprocal of sine is cosecant. We learned that the reciprocal of cosine was secant. We learned that the reciprocal of tangent was, and when we say reciprocal, what do we really mean? 1 over, right? So the reciprocal of sine is cosecant. 1 over sine is cosecant. Okay, those are the reciprocal things, and we've already learned about those. And if we knew our green stuff, we could figure out that just by reciprocating. Is the reciprocal the same sign or different sign? Same sign. When you take the reciprocal, you leave the sign alone. Okay, you got to remember that. So we should be able to handle all those just from knowing our reciprocal functions. All right. So let's just throw some of that out there. Let's do one other thing first. Let's talk about inverse or arc functions. The inverse of sine is arc sine. And what it looks like on the graphing calculator is that, and that's how you write it. It's raised to the -1 power. I can't get it. Now, this creates a problem that we've talked about before. -1 exponent really means the reciprocal, but it doesn't on these functions. Okay? It can't on these functions. So the button on the calculator that's sine -1 doesn't mean the reciprocal of it. It means arc sine. That's how you read it. And it's how you undo sine. You undo sine. If you was in my Algebra 1 class, I talk about doing and undoing. Division undoes multiplication. Arc sine undoes sine. Cosine. The inverse of cosine is arc cosine, which looks like this. And the inverse of tangent is arc tangent, which looks like that. Now what I'm fixing to do is we're going to take that information, and I'm just going to start writing questions out one at a time, and we're just going to pop off the answers. And we're going to kind of do that for a while to get this down, and then the next recording we'll actually go over the worksheet, okay, and use it. But I want us to get it down first. Okay, let's say that I said find the sine of 30 degrees. What would you say? 1/2. What if I told you to give me the arc sine of 1/2? What would you get? It's not reciprocal. The -1 on a function doesn't mean reciprocal. It means arc. It means undo. Now, y'all watch this. This is important for us to get down. When we're saying do sine, what are we going from? We're going from an angle to a ratio. You understand that? If I'm going to do the inverse of that, what would I be going from? The ratio back to the angle. In other words, what angle has a sine of 1/2? 30 degrees. Do you see that arc sine is going backwards, just like division is backwards of multiplication? Okay? We're going to do this enough to get it down before we start practicing it. We just want to kind of make sure we understand it. So sine 30 is taking us from the angle to the ratio. Inverse sine ratio takes us back to the angle. Okay? Yes. So what if I did this? What if I said, okay, I want the sine of 30 degrees. And then I want the arc sine of that. So what is the arc sine of the sine of 30? Well, what is the sine of 30? 1/2. What is the arc that looks like this? What is the inverse sine of 1/2? So the arc sine of sine, see, it's going to take you right back there. If the question was what's the arc sine of the sine of 30, the sine of 30 is a half. The arc sine of a half takes you back to 30. In other words, the arc sine cancels the sine. You just get the 30. Y'all seeing that happening? We're just playing with it till we can get it in our brains. Okay? Yes. You're doing the function of a function. You're undoing the function with its inverse. Right. Right. Okay, so then let's just throw some more stuff out here. Let's say that we wanted tangent negative 1 of negative square root 3. Tangent negative 1 of negative square root 3. All right, so here's what you got to think. What angle has a tangent of square root 3? 60. But it's negative, which means it would be in quadrant 2 or 4. And if it was in 2 with a reference angle of 60, it would be 60 before 120. And if it was in quadrant 4 with a reference angle of 60, it would be 60 before 360, which would be 300. Wow. Okay. We'll let you think on that a second, and then we'll say it again. Okay? You see, all this stuff can happen in your head. We didn't even use a calculator. All this junk's coming right out of our noggins. Okay? We're thinking, okay, I want to know what angle has a ratio of this. Well, the angle associated with square root 3 for tangent is 60 degrees. So I know it's 60, but it's negative. And I've got to think about where tangent is negative. When I go back to this, tangent is positive here and here. Therefore, tangent is negative in quadrants 2 and 4. If I'm talking about 60 degrees in quadrant 1, that puts me 60 degrees before the 180, which is 120. And if I'm talking about 60 degrees in quadrant 4, that puts me 60 degrees before 360, which is 300. That got ugly over there, but you got the point. See what's happening? So what we're learning here has to be committed to memory, because we don't use a calculator to untangle this. We use our minds and our reference angles and our what's positive where, and the green stuff we memorized. Okay? All right. All right, let's just throw one more out, and then we're going to stop and let our brains rest for a second. So let's say that we had the inverse sine of negative 1. I'm going to put this in the inverse sine of negative 1. So we're thinking, what are we thinking? What angle has a sine of negative 1? Well, the sine of 90 is 1, but it's the negative of that. That's my quadrantal angle, 270. Quadrantal angles change signs. That's probably enough for one day. Wow. Any questions on that? This would be a good video to watch again and again and again if you need to. It's at math.prairieland.net. At least it will be in about 35 minutes. All right. Appreciate your